So numerical integration means the numeric evaluation of integrals j equal to integral a to b f of x dx, where a and b are given and f is a function given analytically by a formula or empirically by a table of values. Okay, so that means sometimes it's very difficult to integrate functions like e raised to minus x square dx. So we have, there is no antiderivative for this function, so we cannot use any formula for finding integral of this function. So the only method is we can use numerical techniques. So one of the method to find numerical integration is integral value is trapezoidal rule. So let me discuss what is trapezoidal rule. Okay. So actually, if we have to integrate a function a to b, so this is f of x. So if we have to integrate integral a to b f of x dx, so what we will do is we will cut it into this interval a to b. We will partition it into n intervals. That means a, this is a x1 x1 sorry x0 x1 x2 etc. up to xn minus 1, and b, the term is xn, b equal to xn, and this is x1 x2, a equal to x0. Okay, so we will cut it into n intervals, and each interval is equally spaced. That means this uh, x0 minus x1 is some h, this length is h, etc. Now what we will do is so that is h is equal to, actually the length is b minus a by n. So this you have to note, h is, so the idea is we will cut it into trapezoids like so, and we will add so this is a trapezoid. So instead of rectangle we will use trapezoids to find the area. Similarly, so in order to find the area under this curve, so actually integral a to b f of x dx is area under the curve f of x. Okay, so in order to get the integral value, what we will do is we will find area of these trapezoids. So trapezoids. So a, this is actually first trapezoid f of a, f of x1, and this length is h. So the integral a to b f of x dx is actually equal to sum of the areas of trapezoids. So this area, this integral value is sum of the areas of this trapezoid. That means approximately equal to sum of the areas of these trapezoids. Okay, so that's equal to, and we know that area of a trapezoid is, so this is approximately equal to first trapezoid is actually like this, right? So this length is h, and this length is f of a, this length is f of b, then area is sorry, f of this is a x1. Okay, so this length is f of x1. So the area is actually, area of a trapezoid is f of a plus f of x1 divided by 2 into h, this length. So similarly, plus the area of this trapezoid is uh, f of x1 plus f of x2 divided by h, sorry, divided by 2 into h plus etc. The last trapezoid is this trapezoid. So this is f of xn minus 1, f of b. So f of xn minus 1 plus f of b divided by 2 into h. Now, therefore, the integral becomes, if we add all those all those values, so I can take h by 2 outside. Okay, h by 2 is common everywhere. So I am taking h by 2 outside, and okay, now f of a is only 1, right? F of a by 2. So I am taking f of a by 2 plus here f of x1 by 2, and here also f of x1 by 2. So f of x1 by 2 plus f of x1 by 2 is f of x1. Plus similarly here f of x2 by 2, and also the other term contains f of x2 by 2, that is f of x2 plus etc. f of xn minus 1 plus, and the last term f of b is only once, f of b by 2. So this is the formula for finding uh, uh, numerical integration. So where h is equal to b minus a by n. So now I will write what is trapezoidal uh, rule for integration. So the trapezoidal rule is, so you have to study this formula, trapezoidal rule. So the integral a to b f of x dx is equal to h by 2 into, sorry, there is no, okay, so sorry, there is no h by 2, so I am taking everything here. Okay, if you are taking h by 2, then f of a plus 2 into f of a plus 1, etc. So I am not taking h by 2. So h, I am only taking h into f of a by 2 plus f of x1 plus f of x2 plus etc. f of xn minus 1 plus f of b by 2, where h is equal to b minus a by n. So b minus a by n. So only you have to study this formula. So anybody have any doubt? So you have to study this formula, h into f of a by 2 plus f of x1 plus f of x2 plus etc. f of xn minus 1 plus f of b by 2. So I am only taking here h outside. Okay. Now we will do few problems, and problems are very easy. Okay. So the problem, first problem is, find the value First problem. First problem. Find the value. Find the value. Uh, Integral 0 to 1 x raised to 4 dx. Taking here h is given. H is equal to 0.5 and also h is equal to 0.25 using trapezoidal rule. So we have given the interval length. In first case 0.5 and second case 0.25. Now we have to integrate this. So we will do first problem, first part. That means h is equal to 0.25. So given f of x equal to x raised to 4 and h is equal to 0.5. Now we will do we will draw a table. We will draw a table. First I will write x values here, x values, and here f of x is equal to x raised to 4. So here h is equal to 0.5, therefore the first value, and we have to integrate integral 0 to 1 x raised to 4 dx. So the first x value is 0, 0, and f of 0 is x raised to 0, so that is 0. Now second value is 0 plus 0.5 plus h, right? So the second value is 0.5 and 0.5 I am writing here 0.5 all raised to 4, that is equal to 0.0625. And third value next is this plus h, that is 0.5 plus 0.5, that is 1. So I am writing here 1 raised to 4 is 1, which implies now integral. First we will write the formula. Integral a to b f of x dx is equal to h into f of a by 2 plus f of x1 plus f of x2 plus etc. f of xn minus 1 plus f of b by 2. Now this is equal to, now we have to integrate from 0 to 1 x raised to 4 dx. H is 0.5, f of a by 2. F of a is f of 0. That means f of 0 by 2 plus we have f of 0.5 plus f of 1 by 2. So the first and last we have by 2 terms. So this is 0.5 into f of 0, that is 0 by 2, that is 0, plus of 0.5, 0.0625 plus 1 by 2. 1 by 2 is 0.5. So the answer is, if you calculate this, you will get 0.28125. So this is the trapezoidal rule. Now, if a second question is like h is equal to 0.25. Now you write down the table. What is the value? H is equal to 0.25. The second question, we have H is given as 0.x. F of x equal to x raised to 4. Now tell me, and we have to integrate integral 0 to 1 x raised to 4 dx. Okay, so the first value is 0. 0 raised to 4 is 0. And what is the second value? Tell me. Second value in the here h is 0.25. So x1 is x1 ആരെങ്കിലും പറഞ്ഞേ x1 എന്താ വരും 0 is there. Then the second value we have h. So 0 plus 0.25. So this is 0.25. And the value is 0.25. F of x is 0.25 all raised to 4. From the calculator it is 0.00396. Now the third value 0.25 plus 0.25. That is 0.5. And here 0.5 all raised to 4. That is equal to 0.0625. And next value is 0.75. So the value is 0.75 all raised to 4, which is equal to 0.3164. From the calculator we can easily calculate this. And last value, so we will reach at B. A is this and B is 1. So last value is 1. 1. So 1 raised to 4 is 1. So therefore integral 0 to 1 x raised to 4 dx is equal to, by trapezoidal rule, this is h into f of 0 by 2 plus f of 0.25 plus f of 0.5 plus next is f of 0.75 plus last one is f of 1 by 2. So the answer is 0.25 into f of 0 by 2. That is 0 by 2 is 0 plus next value is this. F of 0.25 is 0.00396. F of 0.5 is 0.0625 plus f of 0.75 is 0.3164 and f of 1 by 2 is 0.5. 1 and 1 by 2 is 0. So now if you add and multiply this, you will get 0.2207. So this is the answer. So these questions are very easy to solve. Now we will do one more problem from this session, and then we will move to Simpson's Rule. The next problem is find Second problem. Find the value of integral 0 to 1 dx divided by 1 plus x raised to 4, sorry, x square, 1 plus x square, taking 5 subintervals, by trapezoidal rule, correct to 5 decimal place, correct to 5 significant digits. Compare it with exact value. So the question is, we have to find the value of this integral by using trapezoidal rule, and we have to take 5 subintervals. So 5 subintervals means n equal to 5. We have to cut it into 5 subintervals by trapezoidal rule, and we want it to correct to 5 decimal place, and we have to compute it with the exact value. So we have to calculate this integral directly and compare with the
Yes.
exact.
Yes.
Okay, tell me.
Sir, network issue ഉണ്ടെന്ന് തോന്നുന്നു അല്ലാണ്ട് വോയിസ് ലാഗ് ചെയ്യുന്നു.
Okay. 1 minute. Okay. Am I audible now?
Yes, sir.
So now we have to compare this with the exact value. So first we will find the value, integral value, by using trapezoidal. So given here given f of x is equal to, so the integrand is 1 by 1 plus x square, and also we have to take 5 subintervals. So n equal to 5, and our lower limit is 0 and upper limit is 1, that is a equal to 0, b equal to 1. Now we have to find out h. We know that h is equal to b minus a by n, so that is 1 minus 0 by 5, that is equal to 0.20. So we have find h. So we given that we want to do it in 5 subintervals, therefore n equal to 5, and we find h. Now first we will draw the table. Uh, so the first value, x values, and here f of x equal to 1 by 1 plus x square. So first value is a. A is 0, 0. And 1 by 1 plus 0 square is here, it is 1. And second value is 0 plus 0 0.2. So 0 0.2. And we have to calculate 1 by 1 plus 0 0.2 all square. So the value is 0.961538. So we have to take at least 6 digits. Okay. Now next value is we will add a 0 0.2 to this 0 0.4, and we have to find out 1 by 1 plus 0 0.4 all square. So 1 by 1 plus 0 0.54 all square is 0.862069. And next value is 0.6. Again, if we calculate 1 by 1 plus 0.6 all square is 0.735294. And next value is 0.8. Again, 1 by 1 plus 0.8 all square is 0.609756. And last one. Okay. Now I will write it here. First and last term I will write here. 1 by 1 plus 1 square. So that is 1 by 1 plus 1 square. 1 by 2, that is 0.5. So this is first term and this is last term. Now we will calculate the. So by trapezoidal rule, integral 0 to 1, 1 by 1 plus x square dx is equal to h into f of 0 by 2 plus f of 0.2 plus f of 0.4 plus f of 0.6 plus f of 0.8 plus f of 1 by 2. So this is 0.25, sorry, 20 into 1 by 2. 1 divided by 2 is 1 by 2, that is 0.5, plus, now we will write this 0.961538 plus this 0.862069 plus this 0.735294 plus this 0.609756 plus f of 1 by 2. So remember this 1 by 2. So 0.5 divided by 2 is 0.25. Now add all this and multiply with the 0.2. Now add all this and multiply with the 0.2. From the calculator we will get 0.783714. Okay. Now from the question we have to calculate the error. That means exact value, and then we have to calculate the error. So we know that the exact value integral is integral 0 to 1, 1 by 1 plus x square dx, and we know that this value is tan inverse x 0 to 1, which is equal to tan, from the calculator, tan inverse 1 minus tan inverse 0, which is equal to pi by 4. And if you calculate pi by 4, the value is approximately equal to 53981. Now we will calculate the error. error is, we know that exact value, that is 0. This error is exact value minus approximated value. So exact value is 0.785391 minus 0. This value 78371. If you calculate this, you will get 0.001684. So this is the error. So this is how we can do trapezoidal rule. Okay. So now you can do any problem by using trapezoidal rule. Now there is one more numerical integration techniques which is more accurate than uh, trapezoidal rule, that is Simpson's 1 by 4th rule. Okay, Simpson's 1 by 4th rule. Now we will move to what is called Simpson's rule. Simpson's rule. This rule is also used to find integral value, and this is more accurate method. And let me discuss what is Simpson's rule. I am not going to derive the formula, just I will give the formula. Okay, so here one of the important thing is, if we have to integrate integral a to b f of x dx, that is interval a to b, we will cut it into even number of, that means first note this important point, first we divide the interval a less than x less than b into an even number of equal subintervals. So in last class we can divide it in even or odd number of subintervals, but in this case we can only divide it into even number of subintervals. So this is x naught, and I'm calling this is xn, x2m, 2m, sorry, even number, x1, x2, etc. x2m minus 1, and last one is x2m. So, and the length of the interval is h is equal to b minus a by 2m. So, note this important form. In Simpson's rule, h is b minus a by 2m. M is number of subintervals. M is number of subintervals. 2m is number of subintervals. Sorry, 2m is number of subintervals. Okay. Now the Simpsons rule, I am not deriving this. I will give the formula. So Simpsons rules are derived by using Lagrange interpolation formula, and we are only going to derive giving the formula. So the formula is Simpsons formula. Simpsons formula. So I will define the formula. So the formula is integral a to b f of x dx is equal to, here I am taking h by 3 into f naught that means f of x naught, f naught, that means f of x naught or f of a plus 4 into f1 plus 2 into f2 plus again 4 into f3 plus 2 into f4 plus etc. 2 into f 2m minus 2 plus 4 into f 2m minus 1 plus the last term f2m. So in this formula, the first f naught is actually f of x naught or f of a. Okay, so that is only f naught is there, and for odd terms, that means f of f1, f3, f2m minus 1, all odd terms, the coefficient is 4. So that is 4 into f1. f1 is 4 into f of x1, 4 into f3, that means 4 into f of x3, etc. And for even terms, the coefficient is 2. 2 into f of 2, 2 into f of 4, and etc. 2 into f of 2m minus 1 and f of 2m. So the first and last term is f of 2. So please note down this formula for finding Simpson's. Okay, so now we will do a problem. So Simpson's rule. Okay, so for finding the Simpson's rule, evaluate. So write down a problem. Evaluate integral 0 to 0.4, 0 to 0.4 x into e raised to minus x square dx. So this integration is difficult to perform. So and taking, okay, this we can do, taking 4 subintervals using Simpson's rule. So 4 subintervals means it is even. Okay. Now solution. So first we will write what is f of x, x into e raised to minus x square, and we have a equal to 0 and b equal to 0.4, and we have how many subintervals? 2m. 2m is number of subintervals is 4. So h is equal to b minus a by 2m here. So that is equal to 0.4 minus 0 divided by 0.4. So that is sorry 0. Divided by 4. So that is 0.1. 0.1. So h is 0.1. Now we will write the formula integral a to b f of x dx, that is Simpson's formula, is h by 3 into f of f naught, that is f of x naught. Now order terms 4 into f1 plus even terms 2 into f2 plus 4 into f3 plus 2 into f2 f4 plus etc. 2 into f 2m minus 2 plus 4 into f 2m minus 1 plus last term f2m. Now we will draw the table. So while drawing the table, you should first x terms will be here and f of x term is here. Now f of x terms I am cutting it into three 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 part. Okay. First, so this is x terms and this is f of x is equal to x e raised to minus x square. Now first value is 0 to 0.4. So 0, and for first value I am writing here because the f of x is f of f naught. F naught is uh, f of 0 e raised to minus, that means f of 0 is 0 e raised to minus 0 square, so 0. So the value is 0. Now for second, 0 plus 0.1, and second value is odd term I will write here. So that is equal to 0.099. That is 0.1 into e raised to minus 0. That is 0.1 is 0.1 into e raised to minus 0.1 whole square. From the calculator you will get this value. And 0.2, this is even term, so I am writing it here, 0.1921. And next is odd term, 0.3, first, second, third, fourth. So I am writing it here, 0.27417, and 0.4 is 0.340857. Now you can easily integrate this function. So therefore, integral 0 to 0.4 x e raised to minus x square dx is equal to h by 3 f of 0 plus 4 into f1, that is this, plus 2 into f2, that is this, plus 4 into f3, that is this, and plus the last term. So I am writing last term here 0.340857. Sorry, last term I am writing it here because for last term we are not using 4 or 2, so this is f of 4. Okay. So this is equal to Anybody have any doubt? So 0.1 by 3 into f of 0 is this 0 plus 2 into this is 2's multiple, sorry, 4 multiple. The next is 4 into, sorry, 4 into 0.099 plus 2 into f2, this 0.1921 plus next again 4 multiple of 4, 4 into 0.27417 plus, and last term there is no multiples, so that is 0.340857. Am I audible now?
Yes.
Okay, so the value is just we are applying these values, then you will get the answer. Answer is if you add this 0.1 by 3 divided by 3, f of 0 is 0. Next is a odd term, 4 into this. Next is even term, 2 into this. Next odd term, 4 into this. And the last term, you should write separately. So if you calculate this, you will get the answer as 0.07392. So this is the answer. So Simpson's rule and trapezoidal rule are very easy method. You can easily score marks from. Okay, now I will give you a question, a homework, or I will give you 10 minutes. Please do this problem. Uh, evaluate the integral, integral 0 to 1 e raised to minus x square dx. This is very important problem using Simpson's rule. Simpson's solution. So in order to use Simpson's rule, here f of x is e raised to minus x square, and here it is no okay, Simpson's rule taking 10 subintervals. So we have given 2m is equal to 10. So Simpson's rule, we are taking 2m subintervals, and a equal to 0, b equal to 1. Therefore, h is equal to 1 minus 0 divided by 10. That is 0.1. Okay. Now you draw the table. When you are drawing the table, you just draw like this. X values here. Then for Simpson's rule, you have to just 3, so that it's very easy to uh, write the values in the formulas. So here x values. Here f of x equal to e raised to minus x square. Here odd values and here even value. And here the first value and last value. So first value 0, e raised to 0 square is here 1. And second value is 0.1 and e raised to minus 0.1. Second value, and that means x1, odd value. First x1 is this is x naught, x1. So I'm writing it here. It is 0.99005. So similarly, you do all those values and you write down and you do this problem 0.1 by using Simpson's rule. And